it's related to it's basically something that you can use. It's rules that you can use for triangles that aren't right angles. So SOHCAHTOA is used for right angle triangles, right, and you can only use it for right angle triangles. It won't work for other types of triangles. Whereas the sine rule and the cosine rule do work for other types of triangles. So this is the sine rule, and it's not written very neatly actually, but so I'm going to write it on this board here. Myself, I think that they could sort out their formatting a little bit better, but it's a over sine A, and is equal to, and I'll explain what this means in a moment, B over sine B, and that's equal to little c over, these are little letters at the top and big letters at the bottom. So what are all these? The little letters are lengths of the lengths on the triangle. The big letters are angles. And essentially, if you draw any triangle at all, you can label all the different angles as A, B, and C, and then you would label the sides as the opposite sides. So the A side is opposite the A angle. The C side is opposite the C angle. The B side is opposite the B angle. So that's how you start off by labeling a triangle. And then it turns out that you can relate all of these angles and sides using these formulae. So whatever the size of the angles or the size of the sides are, it's always going to be true that the length of the side, let's say that's 3 centimeters, and that's 20 degrees. Well, and maybe we know that C is 5 centimeters, then we can find our angle, this angle, capital C here, because it's always going to be that the side, so 3, we're going to say everything's in centimeters, right? Well, that's just right. It's 3 centimeters divided by sine 20 is equal to 5 centimeters over sine whatever C is. And then you can rearrange that to find out what C is, and that's how you would find out the angle. So that's the sine rule. The sine rule is by far the easiest one to remember. It's nice and simple. A over sine A equals B over sine B is equal to C over sine C. The only mistake some people might make is they confuse that second equal sign with a plus sign. But it's not. It's just relating the sides and the angles of any triangle. Okay? So that's the sine rule. So let me just pause that. And you can maybe take a snapshot of that. So that's the sine rule. And if we scroll down, we'll see the cosine rule. And it looks like we've got a little video, their own little video there that you can watch. What's the cosine rule then? The cosine rule also works for every triangle. And it's this. It resembles the Pythagoras rule. Okay. And in fact, if you play around with it, you'll see that it ends up being the same as the Pythagoras rule if it's a right angle triangle, but I won't bother doing that right now. Again, don't worry about which side is which and whatever. It doesn't matter. If you are trying to find out a particular angle and you've got loads of sides, then you use this formula, because it's got only one angle in the formula. Or if you know only one angle but you don't need to know any other angles, again, use this formula, cosine rule. The cosine rule formula. And they've just rearranged it there, so it looks a little bit more like the Pythagoras rule, right? Okay. I won't go into too much detail about that, but that's what. Now we know what they mean by it's. They're using the same terminology. Little a, little b, little c are the lengths of the triangle, and the capital letters are the angle. So this angle A is the angle that's opposite that side A there. And there's a video here that explains it as well. And we're going to apply them to some questions in a moment as well. So before that, though, let's have a look at the last one, which is just the area, again, of any triangle. hopefully. I'll have it maybe on a different page. Let me just find the formula for the area of a triangle. So finally, the area of a triangle can be calculated by okay, so this time A is going to be a different A, right? So it's going to be A for area is equal to half multiplied by AB sine C. So it's the where the C is the angle that's opposite that the side is not being talked about. So for this one I might want to just draw a triangle briefly. So any triangle at all. Doesn't need to be any type of triangle, and that would be, if I just label that as angle A, that would mean that was side A. I label that as side B, that would mean that angle would be side B. So that must be side angle C, and that's side C. So I could work out the area by doing half multiplied by AB, and it doesn't need to be okay. Yeah, so I'll do AB. So it could be these two sides, but I could have labeled this triangle differently, right? I could have switched any of them around, so long as the A is opposite the A, the C is opposite the C, and the B is opposite the B. But so half AB sine C. So that's the area of the triangle formula. So those are the three formulas that we're going to be looking at to answer some questions. So I'll just pause that video there. Okay, so we've got, let me just hide that. Let me just calibrate that as well. Okay, so we've got a triangle here. They've been a little bit nice to you because they've labeled A, B, and C as the corners, which then you can, oh, okay, well then they've used this kind of notation. So BAC is essentially what A would be using the sine rule, the cosine rule, and ABC would be whatever we call B. So yeah. Oh, when you label the sides, you want to use lowercase letters, otherwise you're going to get confused. So we use big letters for the angles and small letters for the sides. Okay. So that would be little a. So when we want to find x, we want to be thinking little a. Okay, and c, little c, they look the same, don't they? So give your answer to two decimal places. Right. Well, we've got two angles. So basically that suggests you're going to want to use the sine rule, because with the sine rules there's multiple angles. With the cosine rule there's only one angle. So we've got, we know that, let's just rewrite the angle, the formula out. So A over sine capital A, which is the angle, is equal to B over sine B. Now I could do equals C over sine C, but that's not necessary. I'm simply saying that any two relationships between the side and the opposite angle are equal to one another. Okay, so the ratio between the side and the length of the side and the sine of its opposite angle, that ratio, that fraction, is equal to any other fraction on the same triangle. So we've got, in other words, in this case, we can say that x over sine 30. Let's use a bit of colour so you can see what I'm doing. So basically what I've just done now is I've done the left-hand part of it. And then I can say that that's equal to, so in any other side now, well, I may as, yeah, so I'm, again, they could have, so they could have labeled this anything they want, but we've got an angle and we've got an opposite side, so we use that one. We wouldn't use this one because we don't have any information about it, so it's not going to help us. So then we could say that's going to be equal to 5 over sine 80. Okay, and then you just rearrange it. So I'm going to use a different colour to rearrange it. I'm going to use black. I'm going to multiply everything by sine 30. So x is equal to 5 sine 30 divided by sine 80. And that should give you the answer. Okay, so I've got the calculator here. So 5 multiplied by sine 30. Oh, great. I need. Okay, I'm going to do it on my. I'm not familiar with using that one. I'm going to do it on my calculator here, off screen, I'm afraid. So 5 times sine 30, then divide all that by sine 80, and 2.5385. So 2.5 is fine. 2.5 centimeters. Okay, two decimal places. Sorry, two decimal places. 2.54 then. So the answer is 2.54 centimeters. Okay. So that's that one. So I'll stop that video there, and that can just be a reminder of how to do that question. Maybe I'll make a second video for the second question if we get stuck.